In this lesson, we're going to cover area of circles and sectors. So the area of a circle is given by the formula A equals pi r squared, where A represents the area and r represents the radius of the circle. So we're going to start off by looking at a few examples using this formula and solving for different things. So on the first one, we're going to find the area. So here we have a circle that has a radius of 31 centimeters. So I'm going to use my circle formula, A equals pi r squared, and then I'm going to plug 31 in for r. So A equals pi times 31 squared. So we can write this as an exact area or as a rounded area. So first let's write this exact. So to write it exact, I'm going to type in 31 squared, but leave off the pi. So 31 squared is 961. So the area of this circle would be 961 pi. And then my units here, since I'm talking about the space that's filled up inside the circle, that's in 2 dimensions. So this is going to be centimeters squared or square centimeters. So that's the exact answer. The other thing I can do is I can also find an approximation. So to find an approximation, I'm going to do 961 times pi, and let's round this to the nearest hundredth. So that's 2 decimal places, so this would be 3019.07 if I round to the nearest tenth. The units stay the same, square centimeters, but that's my approximate. So since it's approximate, I'm going to use this approximate equal sign, the wavy equal sign. All right, on our next example, here we're given the area and we're going to find the radius. So it's still the circle formula. The area is pi r squared, but this time I was given the area. So this is going to say 84 equals pi r squared. And there is multiplication in between that pi and that radius. So the first thing I need to do is get rid of the pi. And to do that, I'm going to divide both sides by pi. And since I have something that's squared and I have pi, I have 2 things that are going to produce irrational numbers. Let's go on and start approximating here. So this is 84 divided by pi, which is 26.74 if I round to the nearest hundredths. And then I have r squared. So to get rid of an exponent of 2, I'm going to use the square root. I'm going to do the square root of both sides. So I'm going to do the square root of 26.74, and that is 5.17. So the radius is approximately 5.17. Now the radius is just the length, that's just 1 dimension. So this is 5.17 feet. If I was doing area, that's when it's squared, but this is just the length, so it's the regular feet. And on our last example here, we're going to find the diameter. So our area formula, of course, only has a radius version. So we're going to have to find the radius first, and then we can convert that into the diameter. So since this gives me the area of 48, I'm going to say 48 equals pi r squared. And I'm going to divide both sides by pi again to get rid of that pi up front and get the r squared by itself. So I'm going to go on and start rounding here again. So that's 15.28 equals r squared. So to get the r by itself, I need to take the square root of both sides. So I'll do the square root of 15.28, and that gives me 3.91 for the radius. But this didn't ask for the radius, it asked for the diameter. So the diameter is twice as long as the radius. So I'm going to do 3.91 times 2, and I get 7.82. So the diameter is 7.82. Now this is still just a length, so the area was in square inches. This is going to be 7.82 inches. So to find the area of a circle, we use that area formula. The next thing we're going to talk about are sectors. And a sector is a region that is bound by 2 radii of the circle and the intercepted arc. So let's think about a pizza. So if you have the whole pizza, then that's a circle. But once you take a slice out, that slice is a sector of that circle that makes up the pizza. So it is bounded by the two radii. So those two sides come out from the center point, and then the arc in between them. And so everything inside of there is called a sector. So the area of a sector compared to the area of a circle, that is proportional to the arc measure and the whole circle, 360 degrees. So the area of the sector over the area of the whole circle would be the same as the measure of that intercepted arc over the whole circle, 360 degrees. So here we're going to find the area of the sectors using that relationship. So if I'm trying to find the area of the sector, I'm going to call that x. So the area of the sector x over the whole circle area. So to find the area of this circle, my radius is 3, so this would be pi times 3 squared. So if I want this to be the exact area, that would be 9 pi, because 3 squared is 3 times 3. So the area of this entire circle is 9 pi. So the ratio of x, the area of the sector, over 9 pi, which is the area of the entire circle, is going to equal the ratio of the arc measure. So since this is a right angle, that arc measure is going to be 90 degrees over the entire circle, which was 360 degrees. So to solve this, I can cross multiply. So if I cross multiply, I'm going to have 360x equals, and then I'm going to leave this in terms of pi at first. So I'm just going to multiply 90 times 9, and that's 810. And that's 810 pi because I only multiplied the numbers out front. The pi is still hanging out at the back. So to get the x by itself, I'm going to divide both of these sides by 360. So again, to leave it in terms of pi, I'm going to divide only the numbers that are out front. So that's 810 divided by 360. So that doesn't come out to a whole number. It gives me a fraction. So on Desmos, if you're using the Desmos calculator, you can press this little fraction and it will put it back into a reduced fraction for you. So x equals 9, and then there's still a pi up here with it, over 4. So 9 pi over 4. We can also estimate that, which means that I would take the 9 pi over 4, and let's just go back up here into my original problem and put my pi up there with the 810. So if I estimate this, and if I round to the nearest, let's do the 10th this time, that's 1 decimal place, so that would be 7.1. Again, we're talking about area, so that's going to be square units, so this is square inches for this one. So exact answers or approximations. So let's look at our next one. So here I'm given the arc measure is 52 degrees and the radius of this circle is 17. So let's go in and find the area of the entire circle. It's going to be pi times 17 squared. So on my calculator, I'm just going to do the 17 squared so that I can have an exact answer. So it's 289 pi. So if we call the area of that sector x, then x over the entire area, 289 pi, is going to be equal to the arc measure, which is 52 degrees, over the entire circle, which is 360 degrees. So let's go through and let's cross multiply. So 360x, and then whenever I multiply over here, I'm going to do 52 times 289. That gives me 15,028, and there's a pi hanging out at the end. So to get the value of x, I'm going to divide by 360. So I'm going to take this 15,028 and I'm going to divide it by 360. Let me type that in again just to make sure it does it correctly. And it's given me a fraction, so let's turn that back, or a decimal, so let's turn that back into a fraction. So this fraction is not very small. So this is 3,757 pi over 90. That's probably something that exact answer isn't as helpful as the approximation would be. So let's go in and approximate that. So I'll go back up in here and I'll put my pi symbol with that 15,028. And so my approximation is 131.1 if we round to the nearest tenth. So this would be square feet. All right, if we look at this last one, notice that there are two shaded sectors. So what I know is that this angle right here is 75. If I think about the whole angle over here, those are a linear pair. So to find the measure of that other angle, I can do 180 minus 75, and that'll give me 105. And since these are vertical angles, this would be 105 as well. So the entire shaded area underneath that arc, there are two of those 105 sections. So let's do 105 times 2. So the total area the total arc measure that is shaded underneath is 210. So whenever I'm talking about the arc measure, I'm going to use 210 degrees out of the entire circle. So I'm wanting to find the area that is shaded, and that includes both of these. So I'm going to call that X. And then I need to find the area of this whole circle. So the area of this circle is going to be pi times 11 squared. So if I do 11 squared, I get 121. So this is 121 pi for the whole area. And now I can go through and I can cross multiply. So I get 360x equals, then I'm going to do 121 times 210. And that is 25,410. And then I put the pi with it. So again, I have a guess that this isn't going to come out as a very nice fraction, but we can do that to get our exact answer. So if I do 25,410 divided by 360, not a nice decimal. It's a little nicer than the last one. So the exact area of those sectors would be 847, don't forget the pi, over 12. So now let's go back in and get our approximation. So I'm going to come up here and I'm going to type that pi up at the top with the 25,410, and that's approximately 221.7. And it's units squared for area, so this is square inches. So with this process, we can use this, or we can use other things that we know to figure out shaded areas that have to do with circles. So on this first one where we're finding the area of the shaded region, I have a equilateral triangle inscribed inside of a circle. So what I have to do to get the shaded area is I need to find the area of the whole circle, and then I need to subtract the area of that equilateral triangle. So let's start out by looking just at that circle. So the area of the circle is going to be pi r squared. So the radius here, this goes from the center. So the radius of the circle is 6 inches. So if I plug that in, the area will be pi times 6 squared. So that's 36 pi. Or I can approximate that. 36 times pi is 113.1. So if that's 113.1, that would be if the whole circle was shaded in. Now I need to take out the part that is within that triangle. So what I'm given here, this is also the radius of the triangle. So I can drop a perpendicular down, and that would make my apothem. So I'm just going to kind of rotate this triangle over this way so I can see it a little bit better. That was a really bad triangle. So here's the right triangle that we're dealing with. The hypotenuse is 6. but we need to figure out what the angle measure is. So let's look at this angle measure at top. So that's going to be half of the central angle here. So I'm going to take the full circle, 360, and I'm going to divide it by 3 because there are 3 sides on a triangle. So whenever I do that, I get 120. So now, to find that top angle, I'm going to do half of that. So I do 120 divided by 2 to get 60. So this top angle up here is 60 degrees. That means that since this is a right triangle, this other angle has to be 30 degrees. So this is a special right triangle. It is a 30, 60, 90 triangle. So in a 30, 60, 90 triangle, the shortest side is across from the 30-degree angle. So we'll call this one A, which works out because it's our apothem. Then our hypotenuse is twice as long, so that's 2 times whatever A is. So from that, I can tell if 6 is twice as long as that shortest side, then the shortest side is going to be 3. 3 times 2 is 6 to get me the hypotenuse. The longer leg of a 30, 60, 90 triangle is the shortest side times the square root of 3. So this one, it's written like A root 3. Since I know that the value of A is 3, this longer side is going to be 3 root 3. So the apothem here is 3, and the side length is 3 root 3. So we have 2 different formulas that we can use for an equilateral triangle. Since we're going to have to find the length of an entire side anyway, I'm going to use the equilateral triangle formula, which is the square root of 3 over 4 times the side squared. That way all we have to do is figure out the length of the whole side. So since 3 root 3 is half of the whole side, I'm going to do 2 times 3 root 3. And whenever we're multiplying square roots, remember only those coefficients, the numbers out front, are going to be multiplied together. So that'll be 2 times 3. So the side length here is going to be 6 root 3. So if we plug this into the formula, we have square root of 3 over 4 times 6 root 3 squared. So I'm going to plug that into my calculator just like it looks. It will be irrational. It will give me a long decimal. So let's go on and get typing. So square root of 3 over 4 times, and I'm going to put this one in parentheses so that the whole thing gets squared, 6 root 3 squared. So whenever I multiply that together, I get the area of that triangle, which is going to be 46.8 if I round to the nearest tenth. So now that I'm going to find the area of the shaded region, what I need to do is I need to do the area of the circle minus the area of the triangle. So I'm going to take the circle and I'm going to subtract out that triangle. So I'm going to do 113.1 minus 46.8. I'm doing it in my calculator over here. So the area of the shaded region is 66.3. Let's put some units on it. Since it was measured in inches and this is area, that is square inches. So 66.3 square inches. Our next one is concentric circles, meaning one inside the other. And we're going to find the area of the shaded parts. So there are 3 circles in this diagram. So I'm going to say that circle number 1 is the outer edge. Circle number 2 is the edge of the white circle. And circle number 3 is the one that's the smaller gray circle inside. So I'm going to need to find the area of all of these circles. Now what I'm given here is that the radius of the biggest circle is 7. So we can go on and find the area of circle 1. So the area of circle 1 is going to be pi times the radius of 7 squared. So if I leave this in an exact, that's going to be 49 pi square centimeters. So since all of these are circles, I can leave these in terms of pi because they will all have a pi in their exact answer. So we're going to stop there for the area of circle 1. Now, once I need to find the area of circle 2, I need to figure out what the radius is going to be. So I need to know what the radius is going to be from here, from the center point out to the edge of that second circle. So I noticed that the white part and the furthest out gray part are marked congruent, and the smallest part is 1 centimeter. So if the whole radius is 7 centimeters, and I know that the smallest part is 1, and then these two are going to be the same, whatever they are. So I'll say 1 plus 2x. So to find the value of x and how thick each of those bands are, I'm going to subtract 1. So I get 6 equals 2x, and then I'll divide by 2. So that tells me that x equals 3. So in order to make a radius of 7, each of these pieces has to be 3 units wide. So the radius of the whole second circle is going to be 4 centimeters because it's the 1 part plus the 3 part. So if I'm going to find the area of circle 2, then I'm going to do pi times 4 squared. So the exact area of circle 2 would be 16 pi. So I have one more circle to do. And this smallest circle has a radius of 1 centimeter. So this is going to be pi times 1 squared. And that just equals out to pi. So if I think about how I'm going to find the area of just the shaded parts, what I need to do is I need to take the outer circle here, and I need to subtract that second circle. So I'm going to have circle 1 minus circle 2. Once I do that, it also subtracts out the smaller circle. So I need to add that back in. So once I get that done, I'm going to add back in circle 3. So I'm going to do 49 pi minus 16 pi plus pi to get my final answer. So the pi kind of works like a variable. I'm just going to add up or subtract off the coefficients. So I'm going to do 49 minus 16 plus 1. And that gives me 34. So that'll be 34 pi square centimeters for the volume of just the shaded parts. If I want to estimate that, so since they all had pi's, I was able to do it that way. If I want to estimate that, I'm going to take that and I'm going to do 34 times pi, which will be approximately 106.8 square centimeters. So it just depends on how the question is asked. All right, our last shaded region example. Here is a circle around a pentagon. So the circle has a radius of 10. So let's start with that circle again. So the area of the circle will be pi r squared. So pi times 10 squared. So that'll be 100 pi. Or I know that both of these answers are going to result in irrational numbers. Let's go on and estimate here from the beginning. So since they were different shapes, I can go on and start estimating. So 100 pi is going to be 314.2. Next, I need to find the area of the pentagon. So the area of the pentagon, we're going to use 1/2 apothem times perimeter. So I'm going to need to know those two pieces of information. So first I'm going to drop a perpendicular so that that becomes the apothem. And I'm going to kind of spin this shape around. I'm going to spin it around so that I can look at it down here outside of that figure. So my hypotenuse is 10. And that angle up at the top that's up here is where that angle from the center point of the circle is. So if I'm looking at this, I want to figure out one of the angle measures to see if it's one of these special right triangles. So I'm going to find the central angle of the entire pentagon. So I'm going to take 360 and I'm going to divide that by 5 for the 5 sides. So the entire central angle here is 72 degrees, but I only need half of that. So I'm going to do 72 divided by 2, And so this little triangle that I'm looking at, this angle is 36 degrees. So there is not a special right triangle that has 36 degrees as one of its sides. So I'm going to have to set up a trig function to help me figure this one out. So I'm going to call this part A because it's the apothem, and then I'm just going to call this one X. I need to figure out both of those because A is the apothem and that's part of my formula. X is part of a side length so that I can find the perimeter. So let's set up a trig function for A first. So if I'm looking from this angle up here at the top, 10 is my hypotenuse. A is going to be adjacent because it's touching that 36-degree angle, and X is going to be the opposite. So if I want to solve for A, and I'm using, that's the adjacent side, and the number I know is the hypotenuse. So adjacent and hypotenuse tells me I need to use cosine. So the cosine of 36 is going to equal A over 10. So to solve this, I need to get rid of this dividing by 10. So I'm going to multiply by 10 on both sides. And that leaves me with A. But over on the other side, I need to do 10 times the cosine of 36. So always make sure that your calculator is in degrees, not radians. So we want it in degrees for whenever we use our sine, our cosine, or our tangent. So this is 10 times cosine of 36. If I change that now, notice that it changes the values. So I want the one that's in degrees. So here, when I do that, A is 8.1 if we round it. So I can go on and plug that into my formula up here. So 1/2 times 8.1. So I still need to find the perimeter, which means I need to find that other length of the triangle, the X value. So there, I'm going to be using opposite and hypotenuse. So if I need to use opposite and hypotenuse, that tells me I need to use the sine ratio. So sine of 36 is going to equal opposite, which is X, over hypotenuse, which is 10. Same thing happens here. I need to multiply both sides by 10. So I'm going to type in 10 times the sine of 36. And I get about 5.9. So that means that this little piece right here is 5.9. So to get the entire side length, that's going to be twice that long. So I'm going to do 5.9 times 2, which gives me 11.8. And then there are 5 total sides. So I'm going to do 11.8 times 5. And that tells me that my perimeter is going to be 59 units. So that's the last piece I need to plug in over here. So the area of the pentagon will be 1/2 times 8.1 times 59, which is 238.95, or if you round that to the 10th, that would be 239. So the last part of this is going to be to find the area of just the shaded region. So I'm going to take the area of the circle. I'm going to do circle minus pentagon to find that final answer. So this will be 314.2 minus 239. And this is an approximation because we've rounded a bunch of stuff. So 314.2 minus 239 gives me an area of 75.2, and that is going to be measured in square inches.